From this presentation onwards, we will try to understand some special types of pointers before moving on to advanced topics like dynamic memory allocation. It is important for us to understand some special pointers. So here is one such special pointer called void pointer. In this presentation, we will try to understand what are void pointers. Okay, so let's get started. What is a void pointer? Void pointer is a pointer which has no associated data type with it. Now, this is an interesting kind of pointer, right? Which has no associated data type. It can point to any data of any data type. Here you can see that void pointer has no associated data type. The speciality of this pointer is that it can point to any data of any data type and can be typecasted to any type as well. Let's discuss one example. Here in this case, let's say we have a main function, and within this main function, we have a variable n which has been initialized with value 10. After that, we have a void pointer. Here you can see this pointer has no associated data type, although it is containing the address of variable n. But I have declared this pointer as a void pointer. This pointer has no associated data type, so it can point to any type of data, as this is what I have written over here. That is why I am initializing this with the address of this variable. After that, we are using this printf function, and here in this printf function you can clearly see that the pointer has been typecasted first and then the dereferences happen. Here you can see that this pointer has been typecasted first. Now what is the meaning of typecasting? It means that you are changing the type of the pointer. Here this pointer is a void pointer. We need to typecast it before using it. That is why typecasting is important. As it is written over here that it can be typecasted to any type, so here we are typecasting it to an integer pointer. Now this pointer becomes an integer pointer, and now we can dereference it without any problem. After dereferencing, the output will be 10, right? Because it contains the address of this variable. When we dereference this pointer, the value 10 will get printed on the screen. So this is what void pointer is, but let me tell you that we cannot dereference a void pointer directly. It is important for us to typecast our pointer before dereferencing it. Here typecasting is very important. So if you are using it directly, then obviously you will get an error message. So you need to be very careful about this. Now you might be having a question why we are even using this pointer. Eventually we need to typecast it to some other pointer. Why can't we simply use an integer pointer? Why we are even bothering about this type of pointer? Why there is a need of typecasting? We have to typecast it, then use it. Why so many things we have to do when we can simply use an integer pointer? Let's discuss the use of void pointer. Malloc and calloc function returns a void pointer. Let me tell you, these are the built-in functions which are used to allocate memory dynamically. We will discuss these two functions later. Right now you should understand that malloc and calloc function returns a void pointer. Due to this reason, they can allocate a memory for any type of data. As I have told you, these are built-in functions that are used to allocate memory. Let me tell you that because these functions return void pointer, they can allocate memory for any type of data. Without knowing the type of data, they can allocate memory. This is the reason why we are using void pointers. Now you can understand why void pointers are so important. Malloc and calloc functions are built-in functions that are used to allocate memory for any type of data. They can do this because they are returning the pointer which are pointing to some memory location without knowing the type of data which will get stored within them. So it is interesting, isn't that so? Here is the syntax of malloc function. You can see over here that malloc function is returning a void pointer, right? I'm just giving you the syntax. Here you don't need to understand this right now. Right now there is no requirement. Malloc and calloc are used to allocate memory at runtime. I have already told you, right? Okay friends, this is it for now. Thank you for watching this presentation.